Common factor, sometimes called GCF, we're gonna look at two or more numbers and see what their greatest factor would be. Now remember, a factor is a number that we use in multiplication to get that particular number. So if we were to look at 6 and 15, and we were going to try to figure out what is the greatest factor that they could have in common. Yes? Now, Alexis here thinks 3 just by looking at it. Now let's put it to the test. Here's what we do. Let's use a factor tree for 6. I'm going to go 2 times 3. They're both primes. So underneath, I'm going to list it again. Okay, 15. What am I going to use in my factor tree for 15? Say?
3 times 5.
That's 5. That's on my list. That's on my list. If I set it up this way, which is a short, well, not really a shortcut, it forces you to see every factor that they have. Now it's my job to see what they have in common. Do they both have any 2's? So they don't have a 2 in common. They both have to have it in order to have it in common. How about any 3's? Do they have any 3's in common, Zay?
Yes.
They don't have to be sitting right on top of each other either. Okay? They have a 3. Do they have anything else in common? 15 has a 5. Does 6 have a 5? No. So our GCF in this case would be 3. Now the old-fashioned way, which, I'm so old, this is how they used to do it. This is what I remember doing. We'd have 6, we'd have 15, and we would list all the factors for each. So we would say 1 times 6, 2 times 3, anything else I can use to get 6? No. In 15, I'd say 1 times 15, 3 times 5. Any other factors I can use? No. So then I would go through and I would circle all the factors they have in common. They both have a 1, no 2, but they have a 3. And I'd say, between a 3 and a 1, which one is biggest? You say the 3. So that would be your GCF. There's a problem with that method. And the problem is, once we start getting into, do you remember a couple of days ago when we had to list the factors? It was for that prime and composite worksheet, list all the factors from least to greatest. Remember that? There are going to be some that you miss because, well, again, a fault of our own by not being thorough enough. Even after going through the divisibility rules and should be able to catch everything, we just miss things. So we use the factor trees now instead to help us with this process. Okay. How about, let's look at 8 and 12. And we'll put these factor trees side by side. Now I know that 8 we called yesterday three-headed monster. It is. So I'm going to rewrite it. Now I know that for today, you tidied everything up and you put everything in exponent form. I think it's probably wiser for today when you're finding GCF to write these out the long way, and I'll show you why. 12, let's go 3 times 4. 3 is on my list. 2 and 2. So in order, I've got 2, 2, and 3. Okay? So now, I'm going to find out what they have in common. They have a 2, so I'm going to write it down. Do they have anything else?
Yes. 4.
They have another 2. Now, what do I do with that other 2? Do I add them together? Do I put them together and make a 22? Multiply them. If you have more than one factor in common, you'll multiply them against each other. 2 times 2 will equal 4. 4 is the largest factor that they share. Casper. When? So look in here. Look it up on the board. Remember the last one that we did? We only had 1 3. Therefore, we could just put down the 3. Now, for the 8 and the 12, I had a 2, and I also had another 2. I had 2 2s in common. So I had to take those 2 2s, multiply them to get 4. If you get in the habit, Casimir, of just, okay, I've got that 2, once you circle, write it down. If you have to circle any more, then you just start multiplying. Yes?
So you like, when you do it, do you like, if there's like a circle up and down, like, do you have to like zigzag like you do on the first one?
We only had to zigzag on the first one because why? That's where they were. This is still a 3? This is still a 3? So like I said, they don't have to come right on top of each other like these did. They just have to be the same. Okay? Don't get confused with that. You try one. All right, so 20. Whatever combination you decided, 4 times 5 works out pretty good. So 2, 2, 5. So if we relist 2, 2, 5, 30. Let's go 5 and 6. So for 30, 2, 3, 5. Okay? Casimir, question.
I get that. You not in the circle.
What did you get? What did you get for a bottom line for 20? 5 times what? 5 times 5? Just 5. What did you get for a bottom line for 20? Well, you should have broken down the 4. 4 is not on your list. See, don't forget everything that you did for today with the factor trees. Okay? You need that. You need that to be done correctly in order to succeed at the GCF. Desi? I'm sure there's a lot of other ways. Okay? But this is going to be my way today. Now, they have a 2. If I circle it, what do I do? Write it down. Good. Then I scan carefully. 2, I look at the 2. I don't have to look directly underneath it. I'm looking all over for another 2 down here. Is there one? No. I look at the 5. Oh, I see another 5 right there. Write it down. And then double check what's left. 2 and 3, they're not the same, so we're good. 2 times 5. Your GCF is 10. Yes.
So if there's extra numbers, you just leave them?
There's extra numbers, you just leave them. Yep. Because they just have the 2 in common, right? So if you circle a pair, you just put that 1 down. Yep. Because really, what is the biggest factor? The biggest factor that 20 can have? Biggest one. Biggest one here. 30. Can 20 have 30 as a common factor? No, it's already 20 is the biggest as it can go. So if you're getting something really, really high, bigger than both of them, then yeah, you're going to have an issue. Bigger than either one, you're going to have an issue. So they usually stay somewhat. Greatest common factor, they're usually smaller than what you're working with. Least common multiple are usually bigger. It's kind of opposite, kind of funny how that works. There you go. 24. 3 times 8 works. 8 is the create a monster. right? Because 8 is 2 times 4. 4 breaks down to 2 times 2. So let's do this, because this is really important. 3 2s and a 3. 40. Let's do 5 times 8. 5 is prime. There's that 3-headed monster again. So for 40, 1, 2, 3, and a 5. Good. So they have a 2. I'm going to write it down. They have another 2. And they have another 2. And a 3 and a 5. Those the same? No. Now be careful. This isn't 6. 2 times 2 is 4. 4 times 2 is 8 is your GCF. Huh? Look it. It's right here, people. Right there. There's the 8. See it? 6 isn't even a factor for 40. You can't multiply 6 by anything to get 40. Therefore, you couldn't have it in common with 24. Not possible. Jasmine. I don't know about that. Any sense? Did you get the 2 times 2 times 2? So, what's 2 times 2? 4 times 2. There it is. But does it make sense now? Did you have 6? Four? Did you only use 2 2s? That's fine. Again, it doesn't matter what you use here, because they will all break down to be the same way if you do it right. You'll end up with this if you do it right. So 9 times 11, 9 breaks down to 3 times 3. I see a lot of people that aren't circling their prime numbers, and they're missing them. So really, honestly, does it take that much longer to put a circle around a prime number? No. Why do we put the circles around them? So we know they're done, and we know to bring them down, right? So make sure that you do that, because I had a lot of people with 99, and they had just 3 times 3. But if you don't have the 11, you'll never get the GCF, because that's what we're looking for. The 121 is 11 times 11. Now watch. Don't confuse this. If we circle what they have in common, then what do? We write it down. Are there any other things that they have in common?
No.
Does this 11 that's left match up with anything up top here that's left?
No.
So this is it. It's just 11. I'm not multiplying 11 times 11. That's not, no. They just have one 11 that's in common. Yes, ma'am.
We don't match up the
In order for you to match up to 3, this is for the same number. They have to have it, like the 121 has to have a 3 somewhere. It doesn't. Okay? In common with the other. So this has 2 3s, but it's with the 99. It doesn't really matter. Okay? Your homework? I don't want no homework. How about this? 4 problems. Is that a trap? No, I will pick them. Just wait patiently.
Thank you, Victor.
Huh? Let's not until we make sure that we really got it. Because once we get to LCM,